Well, at the end of the Darth Wall video, I'm fairly sure I said that there would be another robot coming along very soon, and here it is. This is an outweight spinner called Agrajag that I have been working on for about as long as I've been working on the Beetle. As long as I've been working on Darth Wall, both projects have taken a long time to come to fruition. They've done that for their own reasons. Although that reason both times has basically been massive anxiety that I don't really know what I'm doing. This thing has been a challenge. I am not afraid to say that I nearly gave up on this quite a few times. But it's finally here, and it finally works. And I could not be happier with the results. Well, I could be happy with the results, but I'm very happy with the results. This was a step up in a few ways. First of all, it's the first time I deal with a spinner, and there is a lot that comes with that. It's also the first time that I've really needed to be precise. This thing is using nut strip. It's really relying on nut strip for the sort of composition of it, for holding it all together. Unlike other robots I've made in the past, this actually has a lid that screws on. Big upgrade. So there was precision required there. There was also precision required in getting the spinner mounted. You might have seen a while ago I did a test video with the motor and the weapon just on their own. And that showed why you really need to be precise with these things. That didn't go well at all. A lot was learned, so in that respect it went well. But in terms of, if I put that on a robot, that would have been a very bad idea all around. I had intended to make this by hand. I designed it digitally. I designed it completely in 2D as a bunch of sort of 2D projections, with the intention of trying to print that out, stick it down on polycarb, and just spend much longer than usual making sure that I cut it properly. But then the opportunity of CNC came along, and boy have I made use of that. Most of the parts you see on here are actually the first usable parts I ever cut on a CNC machine. There are a couple that have been replaced for various reasons as part of the sort of iterative design on this. But pretty much all of this was the first sort of mechanical cut. We've done some arty things. We haven't done anything mechanical on the machine before. The cuts that are on here actually didn't go very well. So there are slight offsets in places there shouldn't be. But it still all comes together just fine. I did consider a complete redo on it. But the fact it's working, I really don't see the need to use a bunch of material on it. I've managed to dig out, I don't know why this was important to me, but I've managed to dig out a few of the sort of artifacts of that process. So this is the actual sort of what was left of that first run. Issue I had was that the area down here didn't quite cut properly because I hadn't taped it down properly. And at some point, I think the x-axis, which would have been this way, did lose a step at some point. And therefore the contours aren't quite in line with the holes. But they seem to be consistently out, so it kind of works. I've also got just a couple of old parts, really simple mistakes I made. So this one, for example, in the design just had 2 holes that it didn't need still there. So I did a new version without those. And then this is the side panel I had to replace because I forgot that switches existed. It's more a case that I hadn't really planned the switch position yet. I then did make one where I remembered that switches exist, and forgot to leave a slot for the switch itself, so that's still hand-drilled. I think out of pride alone, I might remake that. Other part that I have remade, actually, this is the original base plate. This is 1.5mm polycarbonate. When I first put this together, I didn't do any weight calculation. It came out at about, I think, 155 grams. Most of that was lost through wiring. It's now down at 147. But I did also do a thinner base plate down to 1mm, just to help shave some of that off. And I'm hoping that when I finish shortening some wires, because there are still a couple of wires that I can chop down, I'm hoping I can reinvest that into an extra 0.5mm on the top to take it up to 2. Because at the moment, you'll see this when we spin it up, I can't get to full throttle because there's just too much vibration in this whole system. And that's going to be a thing, that's going to be the way it is. But I'm hoping that at the very least, when it's running inverted, a 2mm base plate will give it enough stability to get up to full speed this way up. I like it hitting low, and it does hit very low. It's almost undercuttery in a way. But, in situations where I really want to beam it, it would be good to be able to do that. That's, I think, all I can think of to talk about the build itself in one monologue on a phone that is quickly running out of memory, and I can see it counting down how long I have. So what we'll do is, we'll cut to a test video. This is a test video I did a little while ago. And then after that, we'll have a quick chat about that video, specifically in terms of the safety precautions that I took doing it. Because we've had too many unsafe testing videos recently, and I want to at least talk through why I think mine was okay. Not perfect, but okay. So, allow me to sort of recreate this test setup, and through doing that I'll explain why I was happy, A, using it, and B, posting this online where people will be able to either criticise it or potentially copy it. Criticising it, great, go for it. Copy it, at your own risk. Please sort of, you know, if you're going to do this, understand the dangers. I hope I do. I hope I'm not in some sort of dangerous part of the Dunning-Kruger curve here, but I'll put this out there and we'll see what people think. Number one, I have a testing platform that is secured down, basically. This is not going anywhere. The width of this board is just right for the wheels to not make contact. So at this point, the wheels, even if they did move during the test, cannot move the robot. To make doubly sure of that, when I'd sort of done preliminary testing of the weapon itself, I knew it was prone to vibration, so I then had a clamp holding the robot itself. I was using this bit of foam just to avoid damage to the robot, which wasn't perfect. I think I needed to crank it down tighter. I have tested it again since and have gone tighter, and the robot has been fine and it hasn't moved during the test. So maybe I should have just been a little braver in terms of trusting the materials and the construction to really get this tightened down. I'm not going to over-tighten that because we're not actually going to turn this on. So at this point, I've got the robot fairly securely down to the board. It's not going to go anywhere. The wheels are completely off of the ground, off of anything. Next thing you'll see is that I'm using a weapon lock. As far as I can tell, not required for an amp weight, but it's something that was required for me to be comfortable working with an amp weight. It's not the best weapon lock in the world. I basically drilled 4 holes in here so that one of them would be available as a weapon locking hole. I do have plans for a better one. So that is locked, not turned on, all good. Transmitter protocol, this is just what I've been taught. I don't know how valid it is, but what I was taught is transmitter on first. So transmitter went on first. Transmitter was well away. You won't see it in my hands when I'm near the robot. So, transmitter is on, power then goes on. Once I hear all the sort of confirmation beeps from everything inside, I'm happy to then remove the weapon lock. I have, by the way, tested the weapon lock under power. It does stop the weapon. At that point, the robot is live. The setup I've put here is very low down. If I put my leg next to it, you'll see it's down at around knee level. So I have a certain amount of confidence, and this isn't perfect, but I have a certain amount of confidence that if this bar did somehow come loose, it's going to stay at roughly that level. Even knowing that, I was wearing eye protection for the whole thing. I was also doing the whole actual part of the test through a window. I've got the shed behind the camera. I was on the inside of the door, looking through the window. For me, that all combines to be safe enough. This is not the gold standard of spinner testing whatsoever. The gold standard would be to have an arena. But I think we do have to be conscious of the fact that most people don't have an arena, and a lot of us probably aren't going to make a small test arena. I'm thinking about it, but that is quite a big step for a lot of people, especially with a first weapon like this. Is it enough? I don't know. It was enough for me to be comfortable. Again, that could be naivety on my part, but I believe that what I did was safe enough. I'd love to go further. Any constructive criticism, absolutely welcome. So there we have it. Now a pair of potentially competitive AWS legal ants. Got some stuff built for Bants as well. I've got the Hello There replica, and also a sort of half-finished Thwack bot that I might finish off at some point. But I think these two definitely scratch the right itches for me. I still love the front hinge as a design, and obviously the success that this had is absolutely worth keeping going with. Got some ideas of what I might do to the weapon to make it a little better, but kind of don't want to mess with it in a way. It's kind of doing well enough as it is. Always my problem with robots. If it ain't broke, don't fix it. I'm not really about improvements necessarily. And then I have what will hopefully scratch the destruction itch. I'm not sure how destructive it's really going to be. I'm not getting it much above 50% throttle. I did the calculations, and theoretically at 100% this has around a 150 mile an hour tip speed. Not sure how much of a difference that actually makes, but I'll only be reaching half of that. I have a feeling from having watched, you know, proper spinners running properly that it's probably not going to be that good. But it is a fun thing to build, and I've learned a huge amount in doing it. This is by far the most I've ever had to squeeze into an ant body. Fill is fairly compact inside, or at least I thought it was at the time. I can see so much air in there now. And this was using a Nano 2, which made things kind of easy. I was going to do this on a Malenki Nano. I literally have it in the shed. I do plan to work with it at some point, but I just had too many anxieties about trying to get the brushless ESC to work with it. And where it's a robot that doesn't particularly rely on its drive, I feel like the Malenki is almost wasted on it. I eventually managed to get everything just about crammed in. It is super tight, but it is all crammed in there. I still need to change things around with the ESC. I don't know if you can see in there, but I have got the pins on at the moment. I want to remove the pins and hard solder the connections instead. There's a lot of extra wire there as well that I haven't yet cut. Other big challenge with this internally was the power distribution. I have here, fresh out of battery jail, the battery that I completely killed. I've had to, for the sort of sake of space, get rid of all connectors apart from the charging cable and hard solder everything, which was fine until I over-discharged this battery. So I then had the very stressful time of hard soldering another one in, which is something that I never wanted to have to do. Hopefully, I will avoid that in future. But I think if this is the only victim of getting this going, I'd say that's pretty good trade-off. That and it's quite a hole in my wallet. Spinners are so much more expensive than everything else. But hopefully, there'll be a chance to compete with it this year. I look forward to it failing spectacularly. Probably self-destructing at some point. I'm imagining there being a fault line somewhere around like where these holes are. I imagine that's where it will eventually snap itself off when I try and throw it up to 100% recklessly. But all in all, a 100% successful weekend. Once again, this was completed with the help, support, love and care of the BBB build weekend. So, yeah, build things.